Okay, so my name is Eddie Wassef, and I come from Dallas, Texas, like I was saying. I am a husband, father, exhausted father at this point, developer and architect. I've been doing open source software for quite a while. I'm a fanboy of it. I contribute and I speak about open source and thought leadership around all these kind of different topics. I love to fish and hunt. I love to sous vide and barbecue because I'm from Texas. And I'm the VP and chief architect at Vonage, which is a part of Ericsson. And man, I am one of those elder millennials. If you've heard that term before, but we're kind of like day walkers. We could translate between Gen X and the Gen Zs. We know a little bit of the terminology, but the reason I say that is because I actually was able to see and remember the analog days. And I remember when computers were something that were privileged to have in your home, right? And I'm sure, some of you may remember, some of you may not. Some of you were like born in the internet days. But the software journey has really been a very interesting one. And I like to usually think about how software relates to human history and how we as developers and architects and IT professionals interact with it, right? Because a lot of times when you're in the middle of it, you don't see it. And so if we think back to the history of software, the Stone Age of software was around the 40s and 50s when you had punch cards and actually pulling cables, right? And when you actually had bugs in your servers, actual bugs, that's where the term debugging came from, right? And this is where it was the early days, but they did some amazing things and they started showing potential. And what came after that is we started seeing, well, it was in military complexes, it was in educational institutions. It was really the Renaissance, right? You had to be part of that clique. You had to work at IBM or HP to be able to have access to it. You had to know someone who knew someone who knew someone to can get you time on the server. Really, it's very much like the Renaissance back in the 60s and 70s. But that sparked a lot of young, smart folks to really start building things like your Apples and your Microsofts. And this is really where I would say the age of empires started coming in. I mean, there's no doubt that Microsoft and Apple were big empires, and they put a computer in everybody's house. And that's when I really started seeing it. In the 80s, we started seeing our first computer. It was put in the living room. You had to wash your hands, and you had to, before you go to work on the keyboard, because crumbs would get in there and you'd be in trouble. And my dad would take away my bike, which was really the only thing I cared about at the time. But this is really when you started seeing a lot of people and a lot of younger generations that were born into it start learning about computers and start innovating. And in the 90s, that's when the internet came about, right? And then now you've got mail, and you've got mail, and you've got mail, and pets.com, and eBay, and PayPal, and everything started happening, and everybody started using it, and there was a huge, huge boom. And everybody wanted to get a computer. And, obviously that bust after a while. We all know the history there. But this was really the beginning of connecting people together and seeing that we can talk to each other. We can share goods and sell goods and, buy pets and buy pet stuff over the internet. And it started showing its potential. Even more smart people were like, well, you know what? I don't want to work for Apple or Microsoft or IBM or some of these. Why do I have to put on a tie, go to work at an enterprise so I can write software? And that's when the open source movement really started happening, right? There was a really disgruntled guy who invented Linux. He said, screw your operating systems, I'm going to do my own and share it with everybody for free. Free software for a free world. Git was a way to share source code safely without any... How many of y'all here remember something like SourceSafe? Oh, that was awful. But yeah, so I'm very thankful for Git and the open source movement. And with the open source movement, we started seeing a lot more people have access to writing codes. And everybody has a computer in their pocket. Back in the early days, I think the phones were a lot cooler. I mean, you had 6 lines of text. If you were a badass, you had 7. You were like Neo with that flip phone, and you had 7 lines of text that you could play Snake on, right? Those were the days. Now, iPhones and Samsungs are nothing compared to that. But we started seeing a rise in mobile. We started seeing apps everywhere. Anything was an app. If you didn't have an app, you didn't matter, right? And as more and more people were using open source software to write applications and put it in people's hands, they wanted to focus on the user experience. They didn't want a server. They didn't want to have to worry about the database. I just want to store my stuff somewhere. And that's really where the cloud took off, right? I don't want to have a whole data center and a server just so I can load up your, what was a famous mobile game? Farmsville State, right? Let me use somebody else for that. And somebody came around and they gave us a way to store state, pay as you go, right? And as that grew, it started becoming a lot more valuable. And we started seeing a lot more capabilities, databases, security, VPNs, compute, Kubernetes, all the things that were spoken about in the talk previously. These are all things that came with the cloud revolution. It was something that we needed to be able to manage at scale, right? And we wanted to be able to do it quickly and see the results. And it wasn't just for app developers anymore. Enterprises started doing it. And this is where we're at now. We're in the age of platform engineering, right? This is where you don't want the developer to go build everything from scratch. You're building for the builders. There's a booth out there for Cube First. That's a perfect example of building for the builders. Why do you want to go and wait 10 months to provision your environment just so you can run on the cloud? When somebody's done it before, let's reuse that capability. And that's really where the age of platform engineering is shining, right? And it's a really vague concept. We're very early in this area. So let's step back and think about what developers had to do with each of those, right? So we understand kind of the concept that the software industry went through. What about developers? Well, in the early days, I think the developers were like, settlers in the new frontier. They went out west and they had to go and break ground. They were self-reliant. They had to do everything themselves. You had to dig a well. You had to dig your own outhouse. You had to build your home. You waited until if a storm came by and blew something over, you had to rebuild it. It was very much reactive, very much self-sustainable, and you didn't really have state-of-the-art, cutting-edge software. But eventually that changed. Eventually the West started getting settled. And you started seeing these towns that came together, right? And this is where development shops started happening, and you had client server, right? And you had, you'd go over, you'd put on your tie, you'd walk over to the DBAs who were very specialized, right? And that's like the bank over there in that building. And they would tell you what you needed to do, and then you'd walk over to the general store, and they'd tell you exactly what you needed to do, and then at 12 or 18 months later, you had a piece of software. But it was better than before. At least we had some specialization, and we had some kind of reusability. I wouldn't say, to some extent, better than before. Then as the Microsofts and the Apples and the Googles started coming together, you really started seeing your empires, right? Probably a better example would be SAP. How many of y'all here worked with SAP? Right? You live in the SAP world, you're in that empire, you had everything you needed, right? And you could go, and as long as you were there, you had your event store, you had your data storage, you had these weird databases that had 52,000 row columns that had no meaning whatsoever, but somehow a view would manifest something that you wanted, and you lived in the empire. You were happy, right? The emperor or the king or whoever you were with, they took care of you. As long as you didn't piss them off, they pissed them off, they'd throw you out the walls, and you were in trouble. Then we had the Industrial Revolution. This coincides with the internet boom, coincided with the apps. This is where we started seeing things like an internet connectivity backbone. I can connect to Civo, I can connect to AWS, I can connect to different cloud providers and get their services, right? I can see something as a service, a database as a service. I could see time series as a service. I could see DNS as a service. Anything that was as a service, this is something that I was able to use as a developer, right? And this is kind of like the Industrial Revolution. It was dirty. It was sometimes inefficient. And we started focusing on business value. And this is where you start seeing a little bit of that come into play. And that as that evolved, as we're getting closer to the platform engineering days, I think we're more in the cosmopolitan area. This is where if you think about historical buildings that were changed into a coffee shop, right? May have been a general store one day and then you had to retrofit it, similar to this building, right, that we were in. These are your Googles, your Microsofts. These are kind of the old guard, and you have your boutique offering, you have your Firebase, you have your Azure stuff. They took something like Azure SQL, great database, let's try to package it together, make it cool, right? Let's throw some latte art on top and ship it out, right? And this is kind of, what we have, and this is where we're at today. But that's still not fast enough, right? Developers want more, and developers are really starting to see themselves wanting to build into these Mid-America master plan communities. And so if you think about this, if you think about as you're driving through and you see some of these new communities, they've got standard 40-foot or 50-foot lots, right? They have standard water pressure, they have standard sewage, they have standard street widths, they have standard mail systems and all of that. And then you can take that and buy standard 2x4s and standard pipes and build anything you want. And that's the perfect metaphor for platform engineering. I don't want to go chop down a tree, cut it into lengths so that I can build something. I can go to Home Depot, which is my platform engineers, and buy my standardized units and buy, oh shit, sorry. That is not supposed to happen. And really start building, things efficiently and creatively. And that's where we're at. But what's next, right? What are we going to build? So now that we understand kind of the concept of I want to be able to build something consistently, quickly, and be able to attack the market. Be able to, somebody over here said something about specialized clouds that have needs for missiles, I think, or something like that. These are all the new requirements that developers are having that they need to be able to address. And how do we get there, right? What do we do next? How do we take the same 50-foot lot, and if you want to build a skyscraper and you just want to build a garden home, and somebody else wants to build a pool, how do we get there? And this is where you really have to take a moment and think about how do you build for the builders? Everybody's heard about these IDPs, internal developer platforms. Why are they important in platform engineering? Right? They're important because you are sharing effectively the Sears catalog, or maybe some of y'all don't know Sears. There used to be a company back in the day, it's like the Amazon catalog, where you can go and you can find everything that you need to be able to build these homes and build this software consistently. There are tools out there like Backstage, like Cortex, like so on, that you can look through these catalogs and put them together. Other tools, for example, your Git, your Argo CDs, your Flux, these are consistent ways for you to reproduce and deliver to your builders consistent CI/CD pipelines, consistent deployment, consistent application sets, right? These are all the things that really you need to think about when you're delivering to your builders. So it's not, I wouldn't say it's necessarily a new way of doing things. As you can see, humanity's been doing it forever, right? But it's a new way for software, and it's a new way of thinking. It's not anything less. You're not necessarily an ops person that's trying to move into the role. You're a developer who's building something for developers to build other pieces of software. So with that, I want you to take away a few things. I want you to think about your day-to-day. I want you to think about what's important for you to share with your developers, with your teams, that doesn't add necessarily business value to your product, but is necessary to deliver your product. Anything that checks that box is a good candidate for platform engineering. So that's your CI/CD, that's your certificate management, that's your DNS, that's potentially your storage, your data storage, or your actual non-structured storage. What else? It could be your monitoring. It could be your recovery. It could be your scaling. All of these things are candidates for you to look at and potentially put into your platform engineering bucket. Think about you're building a way for somebody to build a house. Their foundation is your Kubernetes cluster, or it's your EC2, or it's your Azure Compute, or it's whatever it is. You're going to provide that to them very easily, very quickly. They don't need to think about it. Your monitoring, that's your plumbing and your sewage, right? Your windows, standard sizing. You don't need to have special, weird, wiggly windows. Let's provide that to them. And divide your teams in a way where you can reproduce that and deliver it quickly, and deliver it consistently and abstractly. So with that, let's open up the floor. There's really not a lot of prescription here. This is more of a thought experiment. So anybody have any questions around the topics that we talked about, or any of the products that I mentioned?
Cool, right behind you.
We got one here, we got one here.
Hey, actually, it's going on the last point you just touched on about the teams of the platform deployment. You talk about developing the landscape that creates the platforms that your users, the builders, the developers utilize. How would you go about the approach of looking at the team that is going to scale that out? Do you section them off into specializations with SREs, coders, DBAs, much like how you talked about during the Renaissance or in earlier days where everything was hyper-specialized? Or do you wear everybody wears multiple hats type of platform? How do you see that approach?
So that's an excellent question. So really, I wouldn't necessarily say they should be specialized, or 100% specialized, but I wouldn't necessarily say that anybody could put on that hat. The best team for the job that's delivering something today, because today all of us build everything. We build our infrastructure, our CI/CD, our monitoring, or so on. Collectively create almost, I would say, a SWAT team to build it and deliver it internally, right? Now, SRE and DevOps have always been a very interesting topic between, do I have people dedicated to understanding one application, its infrastructure, and its management, which is SRE, or do I create, a team that does DevOps as a whole? And I think you need to have both. I think you need to have SRE teams for the platform engineering, because now you are effectively a platform provider internally, and you need to treat it that way. So if your application is 2 nines and somebody else's application is 3 nines, the SRE team or the new platform engineering team has to do 3 nines, potentially even higher. And so have your SREs understand those technologies really well, but then potentially build those teams from the best of the different organizations from a coding perspective, an ops perspective, a DBA perspective, and continuously feed it. It's never going to be done, right? We had copper piping for our water. Now we have these flexible, I can't remember, PVC or something like that, with shark bites. You don't have to weld anymore. So there's always evolution. Same thing with our software. You're going to have Argo's hot today. It's not going to be hot tomorrow. Kubernetes is hot today. It's not going to be hot tomorrow. So keep those teams around, right? They can go back and work on the product because that's what brings you money. But they should isolate the product itself and maybe work a virtual team on it until it's ready, and then move back into the other team. We had a question here?
I've kind of got it's a two-part question. How do you think about the build versus buy in the context of platform engineering, where it seems like because everything has become so specialized, you have to build this hyper-specialized platform? And then the second part of the question is, how do you kind of build the business case internally where you're saying there's a bunch of things that aren't value add that we've figured out how to duct tape and glue together and it kind of works, to now let's go spend a bunch of money investing in something that isn't value add to effectively build something that is value add on top of the thing that isn't value add to get back to the place that we are?
Yes. How to deal with executives. That's a good question. Basically, I think that's a summary. So the first part, I love that question. I thank you for almost as if I planted it in there. I don't believe in build versus buy anymore. I believe in whether you build or buy, you need to look at extending and integrating. So it's really build, buy, extend, and integrate. So if you're going to buy something, that's fine, right? How can you extend it? Because you have that hyper specialized need in your system. And how do I integrate it in my other tools? Because again, we're trying to get the DevOps infinity. I need to be able to see that feedback. So whether you build or you buy, I don't think that's really the importance anymore. I think it's how am I going to extend it? Who's going to do that extension so that I can see it, whether it's in my internal developer platform or my Confluence or my Jira. I want to be able to see the value of what I'm doing. And that kind of goes into the second part of the question. How do you translate it to executives that just know funny money, right? And the answer there is you need to look at repeatability. And it's hard because you're trying to, everybody looks at revenue, right? Money in, and we're trying to look at savings, right? And so what you need to start off doing is measuring how long it takes today. And that's really where I think monoliths and microservices are failing in some cases. And people are going back to monoliths because, they're like, well, I don't need to rebuild everything. I could just add another class in here, another endpoint on this monolith, and it'll be good to go. But what happens if that fails? You need to look at all those you need to speak their language. So it's funny money, right? What's the blast radius of something going bad, right? What is the opportunity cost of not being able to deliver on time because I can't build this thing and deploy it once every quarter? And so you take those two, and then you look at that build versus buy equation. Maybe I start really quick by buying something, and then taking maybe 6 or so months to extend it, but then I'm repeatable. And I can show the time it takes me to provision new infrastructure in new regions for the sales guy to get that customer is now 10 minutes versus 12 months. That's dollars that they'll understand. So it's an art. Just like accounting in any business is an art, there's no science to it, trust me, I know. It's the same thing. You got to figure out a way to slice it and dice it. Any other questions? All right, I'm gonna go take 2 Advil from my back, and I'll be around for any additional questions. Thank you.